For our second set of problems with GCF and factoring, we're going to look at some bigger and more complicated problems that GCF allows us to simplify a lot easier. Consider the one on the screen. I could, if I wanted to, FOIL and FOIL on each side and then combine like terms. But that's going to lead to a lot of math and still get me to the same answer as if I thought a little bit about it and looked at it in terms of GCF. So let's go back and look at it in a different way. Let's go ahead and just split this problem in half. And let's look at it as a problem that has two pieces. This piece on that side and that piece on the right-hand side. And let me go ahead and rewrite the problem with some different colors so it's a little bit more easy to see what I want you to see. So I'm going to look at the 2x plus 1, and then the second part is x minus 2. I'm going to keep plus, and then x minus 3, and I'm going to rewrite again x minus 2 in the green. So here in this case, if we look at it as two pieces, and we think of it as GCF, we look at what do these two pieces have in common. Pretty easy to see right now that these two pieces share an x minus 2 in common. So if I want to, I can yank out the common factor, x minus 2, take him away from each of these pieces. And then I have to look at what I'm left with. What has he been distributed to? Well, there's a 2x plus 1 piece, there's a plus sign to drop down, and an x minus 3, all left. Now, if I consider the GCF out front as something that I'm done with, and look only at the inside, then I need to combine like terms, because it's a simple polynomial addition problem, which leaves x minus 2 out front. And if I combine like terms on the inside, combine the x's, I get 3x's. Combine the numbers, I get negative 2. And when I do that, I get my fully factored form, x minus 2 times 3x minus 2. And that's my final answer. It's the same answer I would have arrived at had I FOILed and combined like terms, but in this sense, using GCF got me a lot quicker to my answer and in a lot easier way. I can use the same sort of approach to a lot of different problems. So let's consider this second one. And again, I want to look at splitting him down the middle. And I'm going to rewrite him with some different colors so it's easier for you to see what's going on. So I'm going to rewrite this first term as 3x to the third, and then x plus 2, and lastly, x minus 6. I haven't changed anything, I've just changed the colors. The second term, I'm going to have plus, and then 24x to the third, x minus 6, and 3x minus 4. Again, I haven't changed the problem at all, I've just changed the way that we look at it. And if we look at the colors, the monomials are both in red, and then I have the common binomials in green, and then everything that's left over is in purple. So let's look at the monomials first, the 3x to the third and 24x to the third. And I look at what can I pull out from both of those just using GCF. They each share a 3 and an x to the third. And if I look at it that way, I've taken that whole piece out, and I've taken this whole piece out and left an 8 because I have to divide out the 24 and the 3. Now let's consider the green. Each of my pieces shares an x minus 6 in common. So I can go ahead and yank out the whole x minus 6 term. And he's going to be gone, and he's going to be gone. Now I just have to consider what's left over. So I like to put that in big brackets and go from there. I have an x plus 2 from the first piece, who's going to drop down. And then I also have the plus sign. And don't forget that 8 that we have left over when we divided the 24 by the 3. And lastly, there's a 3x minus 4. So again, what I've pulled out front, the 3x to the third, x minus 6, that's my GCF. I'm done dealing with him. He's just going to chill out front. Now I need to look on the inside here and do some polynomial stuff, distribution, addition, whatever I need to in order to simplify that. So when I go through, the 3x to the third, x minus 6 is still out front. On the inside here, the x plus 2 doesn't need its parentheses, I distribute the 8 to both of the pieces and get 24x minus 32. And in one more step, I'll have my final answer. 3x to the third, x minus 6 is again just chilling out front. And then combine like terms, put the x with the 24x, I end up with 25x's. And put the 2 with the negative 32, I get minus 30. So in the end, my answer has 3 parts, 1 monomial, 2 binomials. And again, I could have FOILed way back up here and distributed and combined like terms, but if I look at this in terms of GCF, it becomes a lot easier when I yank out common terms and then just combine whatever's left.